Thank you, Chair. So, all the message. My name is Timo Keränen. I come from VTT, Technical Research Center of Finland. This work has been performed in EU project called Unicorn, and it is about measuring sustainability of this tire pressure and temperature. So this is the content of my presentation. We have this group project team in this work, totally about having 5 research institutes and 7 companies. And our use case here is Continental use case. So that about this case. So what is the challenge and what would be the solutions? So that there is an enormous amount of tires manufactured, and the number will increase to 5 billion by the end of 2030. And every year, 3 billion tires are recycled or retired. And these about 70% of the tires are recovered. And this in Europe, this about 92% of the tires are recycled in 2020. So what is happening with the tires? So that if the tire is under inflated, it increases fuel consumption and increase of carbon dioxide production. And also, if the tire has correct pressure, it really affects the safety in traffic. And other way around, if the tires are inflated properly, it could create safety hazard in traffic. And RFID is the recycling of tires. And this tire pressure monitoring system provides this capability to decrease this carbon dioxide production and safety in traffic. So, and United Nations and EU had set some sustainability goals in the UN by 2015 and Agenda 2030 about sustainable development. And European Green Deal targets has been set that Europe will be the first neutral continent, climate neutral continent by 2050. And at least 55% less greenhouse production by 2030 compared to the level of 1990. And 3 billion trees, additional trees will be planted in the EU area by 2030. So that there has been this development going on related to this tire pressure measurement, and there is this EU regulation from year 2009 that at November 1st, 2014, all tires need to be equipped with this tire pressure sensing monitoring system. And there's this regulation defines that all new cars after 2014 need to be equipped with this system. And there is these 2 systems in, let's say, historical system, indirect system, which utilizes this APS system, signals detecting these pressure in tires, and more developed one actually measuring the pressure in tires. And we have had 2 concepts in concerning this tire pressure sensing, so that we have made this concept 1 design so that we have utilized passive RFID system, which has this reader device, antenna, RFID chip, pressure sensor electronics. And in this concept 2, we utilize coin battery, pressure sensor electronics, Bluetooth radio, and antenna. and system energy is provided by battery. And both systems utilize biomaterial substrate, additive manufacturing processes, and low temperature bonding process. And this RFID design is basically very simple, low number of components. PLE system require more components, and battery is required in that. And we have made this layout design of the system so that it utilizes RFID UEC component by EM Microelectronic and printed antenna, which enables this communication between RFID and reader. And this energy for the measurement is harvested from the carrier wave of the reader device. And this reader device actually includes this Bluetooth, so that takes care of the communication to the mobile application. And this Gen 2 system is utilizing this pressure sensing component by ST Microelectronics, and that has this sensor component is equipped with the digital output. And these both systems, this circuitry layout design is implemented on substrate by using the screen printing and copper ink, and that is the system layout implementation. And this lifecycle analysis in literature proposes that use of silver ink is not as beneficial as using copper ink in this system implementation. So we tested these copper inks in this implementation on BioPET substrate, and we noticed that this Print CP Copper Plus ink provides these best results. And this drying was performed in 150 degrees Celsius, and that was according to the technical data sheet. And bonding using this low temperature solder was applied this in 156 in Gen 1 and 2 degrees higher temperature with this Gen 2. And that temperature is actually about 90 degrees lower than this commercially applied soldering process with thin silver solder. And then on the right side, you can see the substrate, the assembly of old generation systems. And we made this application, mobile application, in order to contact to the sensors and have the results in that case. So that the timer sampling setting provides measurements by the set time, and there was an option to get a single measurement also. And we set these, we place those sensors in simple garden bottle and increase the pressure in the bottle just by pumping more air into the bottle. And then we measure the what pressure we could get when we increase the pressure from 1 bar normal atmosphere per pressure to 4 bar. And then we decrease back the pressure in the bottle. And here you can see the results. So that on the left side, there is the measurement results provided by the RFID system, this Gen 1 system, and on the right, we have seen the Gen 2 system results. And there could be some interesting features in these measurements, so that we could see that in the Gen 1 and Gen 2 measurement, when we compare those results with this reference provided by Continental pressure check system, there seems to be slight deviation on the measurements, and that is actually true. But some thing behind that is that our system resolution is 1 millibar, and Continental reference is 100 millibar. And we didn't use any third system in order to adjust the pressure in the bottle. And that is actually visible in those figures. Another interesting thing is that when we measure the temperature in the bottle of the sensors, we could see that this sustainable system follows this temperature increase fast in the bottle. But this Continental system sees this change at the end of the sequence. And our interpretation for that is that this thermal mass of the Continental system is making this difference in that measurement. So that maybe the measurement takes maybe longer in this case than in this Gen 2 system case, and this Continental reference reacts with the certain delay for the measurement change, for the temperature change. So we have really the two generations, pressure and temperature sensor, and this Gen 1 was based on RFID, and Gen 2 based on Bluetooth communication and battery. And both systems were implemented on bio-PET substrate, screen printing by copper ink, and low temperature soldering by using this thin bismuth solder and low temperature. And in our case, I would say conclude that we have made the design and functionality verified successfully on these systems. So we thank EU for providing funding for making this study, and we thank also MV Heruka for printing coupling circuitries on bio-PET substrate, and Virpi Jumisko for assisting SMD components bonding on bio-PET substrate. So, thank you.
Thank you.